Okay. Okay, but today's class, just before the second term examination, I would just like to, whatever chapters I can in these 3 days, I would just revise, the important points from the chapters. Okay. So can you all hear me? Can you all hear me?
Yes, sir.
Okay.
Yes, sir.
So welcome to the
Yes,
first
sir.
day of the revision chemistry class, class 11 science. Okay. Today the day one. Now the first thing that I would like to just revise is a topic which is called chemical equivalence. Chemical equivalence. Now, you must know the definition, the meaning of chemical equivalence. Okay, now let me just define it. Chemical equivalent over here, it is also known as equivalent mass. Also known as equivalent mass. Equivalent mass. Equivalent mass, where it is the number of parts. It is the number of parts by mass, by mass of the substance, by mass of the substance which combine, or displace, directly or indirectly, directly or indirectly, 1.008 parts by mass of hydrogen, or 8 parts by mass of oxygen, or we can say 35.5 parts by mass of chlorine, or you can say, if you take silver, 108 parts by mass of silver. Okay, so this is the definition. It is the number of parts by mass of the substance which combine or displace directly or indirectly 1.008 parts by mass of hydrogen, or 8 parts by mass of oxygen, or 35.5 parts by mass of chlorine, or 108 parts by mass of silver. So this definition you must remember. Try to learn this definition. Now I'll quickly revise the equations, the formula required over here. Okay. Now the first one over here, the most important one, the most important formula I'm going to write down is atomic mass. Atomic mass is equal to equivalent mass into valency. Atomic mass is equal to equivalent mass into valency. Please remember this. So how do you get the equivalent mass? The equivalent mass is obtained by dividing the atomic mass by its valency. Now, this was the formula, which is the universal formula for getting the equivalent mass of any substance, any atom of an element. Now, how to determine? For the determination of equivalent mass, there are methods, various methods are there. So here we will determine the equivalent masses one by one. We will just go through the formula only. So I'm going to write down methods for determination Methods for determination of equivalent mass. So under this method of determination of equivalent mass, the first method is called hydrogen displacement method. It is called displacement hydrogen displacement method, where the equivalent mass of metal can be found out. So I write this in short. Equivalent mass of metal is equal to mass of metal divided by mass of hydrogen displaced. Mass of hydrogen gas displaced. Since hydrogen is a gas, so it's an element which we have taken for the hydrogen displacement method. So its atomic mass is 1.008. So if you apply this formula, you will get the equivalent mass of the metal. Suppose there is a reaction between an active metal and acid. Okay. So by using this formula, the amount of hydrogen gas which is displaced, which is given out when the metal is reacting with a particular given acid, can be found out easily by applying this formula. Okay. Otherwise, if you don't use the mass, then you use the volume. So in that case, the same formula becomes equivalent mass of metal is equal to mass of metal divided by volume. Volume, that should be in milliliter. Volume of hydrogen gas displaced at NTP, we can say, normal temperature pressure conditions, into 11,200. Now this 11,200, because the volume of hydrogen gas is in milliliter. So this is the formula which you must remember for determination of equivalent mass of an element, a metallic element, say example, by hydrogen displacement method. So keep this formula in your mind, and you should be able to apply this formula mentally and get the answer. Okay. For simple numericals based on the direct application of this formula.
So volume in ml.
Volume is in milliliter. Volume is in ml, milliliter, ml. Okay, ml, milliliter. Okay. Now that was number one. The second method for the determination of equivalent mass, I'm writing it down now. It is called oxide. It is called oxide formation method. It is called oxide formation method. Suppose magnesium reacts with, say, it reacts with oxygen. Magnesium is burnt in oxygen, it forms magnesium oxide. So by this reaction, you can get the equivalent mass of the metal, magnesium. So the formula is like this: equivalent mass of metal is equal to mass of metallic element, or we can write mass of element divided by mass of oxygen, which is combined. Mass of oxygen into 8. So you apply this formula, get the equivalent mass of the metal by using oxide formation method. Okay, that was number 2. Then number 3, the third method of determination of equivalent mass is here. It is called chloride formation method. It is called chloride. It is called chloride formation. Chloride formation method. So for the chloride formation method, remember the value 35.5. So here for the chloride formation method, again, if you take the mass of chlorine, okay, the atomic mass or whatever it is, the mass of chlorine. So here equivalent mass of metal is equal to mass of metal divided by mass of chlorine formed. Okay, mass of chlorine displaced, you can say, or formed into 35.5. If you take the mass of chlorine which is formed, otherwise if you use the volume, you can apply the next formula. Equivalent mass of metal is equal to mass of metal divided by volume of chlorine at NTP. This volume of chlorine has to be in milliliter, again multiplied by, over here chlorine, no, Cl1. So we'll take 11,200. Okay, we'll take
So this
11,200 because this volume
oxide.
11,200, because see, chlorine is diatomic, no? So we take half of that. Chlorine is a diatomic molecule, hydrogen is a diatomic molecule, so we take half of 22,400 milliliter. Are you getting it? One volume, of any gas occupies 22.4 liters or 22,400 ml. Okay, but since these gases we are talking about are all diatomic over here, so therefore that's why over here we are using 11,200. 11,200, because we have seen the formula over here, that equivalent mass is equal to atomic mass divided by valency. The valency must divide, Okay. So here, that was the third method of determination of equivalent mass, which is called chloride formation method. In a similar way, we have the next one, which is called metal displacement method. It is called,
Sir,
yes.
sir, I had a doubt regarding volume, sir.
Tell me.
So, do we take 22.7 or 22.4 liters,
That is
sir,
at
during conversion?
STP, no? At STP we take 22.4 liters. Okay. But here,
Yes, sir.
but here, since the gases which are like, if it is chlorine, if it is oxygen, okay. So that's why for these things we are using 11,200 ml, half of 22,400 ml. Okay, at STP.
Yes, sir.
It is 22.4 decimeter cube or liters, But here the volume cannot be taken in liters, The volume must be used in milliliter. That's why we are converting that 22.4 liters or decimeter cube to 22,400 centimeter cube and dividing it by 2 to get 11,200 milliliter, or what you call centimeter cube. Am I clear? Am I clear?
Yes, sir, sir. But sometimes they take 22.7, sir. Not
No,
in
no,
this
no,
case,
no.
but
22.7 is wrong.
yes, sir.
22.7 has never been a value of the molar volume or the standard molar volume. Okay. It has been 22.4 only. Okay. Now, for number 4, metal displacement method, the equivalent mass of the metal can be obtained by applying this formula. So the formula goes like this: mass of added metal, divided by mass of metal displaced, mass of metal displaced is equal to whatever metal you are adding, okay, and whatever metal that is being displaced over here, okay, is equal to equivalent mass of metal added divided by equivalent mass of metal that is displaced. So this is the formula which you can apply to determine the equivalent mass of a metal, which is by metal displacement method. Okay. Now the next method, it is called double decomposition method. It is called, this one is for simple displacement reactions. Wherever there is simple displacement reaction, that time, like suppose if you are reacting zinc metal with, say, copper sulfate solution. Okay, so this zinc becomes the mass of this become the metal added, and over here it is formed what, zinc sulfate plus copper, no? So this copper over here, it is the metal which is displaced. So for such situations, whenever there is a simple displacement reaction happening, that time we have to apply this formula, which is called metal displacement method. Okay. Number 5, which is called a double displacement displacement double displacement method, where you must have heard of double displacement reactions, like for example a general equation like this: AB plus, if you react AB or reactant with CD, another reactant, to give the products, say AD plus CB. So these are the products and these two are the reactants. Now if you look at the reactants and the products, each of the reactant or each of the product, they have got two parts in them. One is the cationic part, another one is the what you call anionic part. So to get the equivalent mass, to determine the equivalent mass or equivalent weight by the double displacement method, which is applicable to double decomposition reactions, the formula which can be used is given below. So the formula goes like this: mass of AB divided by mass of AD. Mass of AD, which is equal to equivalent mass of AB divided by equivalent mass of AD. This can be further broken up, okay, going to the elements, the different parts which are present in the reactants of the products. So we can write down equivalent mass of A plus equivalent mass of B divided by equivalent mass of A plus equivalent mass of D. So if you apply this formula for a double decomposition method to determine the equivalent weight, you can get the answer. Okay. Now this was the important formula which you have to remember in your mind for calculations. Okay. Now we move further. Like there are different substances. There are different yes. What is the question?
That I don't understand. So that why is so that previous slide.
Yeah.
So that why is mass of matter displaced AD?
Mass of metal over here. This one. This one.
Yes, sir.
No, no. This is mass of AB. This is mass of AD. No, this one, the product. This is the reactant over here. No, isn't it? This is the product. So
Yes.
when the reactant undergoes reaction, then the product is formed. No, are you getting it? So if you somehow, or if you don't apply this formula, then you have to use either CD or CB this way, because at least one is unknown. No, out of the
Yes.
1, 2, 3, 4 different variables over different identities over here, at least one is unknown. The other three are known to us. No, if you take permutation and combination for AB or AD, or you take permutation combination for CD or CB, at least three are known, then only we can get the fourth one. That's why over here mass of AB, if it is known, mass of AD will be known. And if you know the equivalent mass of A, if you know the equivalent mass of B, then you can easily find, and if you also know the equivalent mass of D, then you can easily find, say, any one of them. So here 1, 2,
Yes.
3, 4. No, are you getting it? So
Yes,
this is
sir.
how we
Yes.
go ahead. So in place of AB and AD, you can also use CD and CB like this. Are you getting it? Okay, so
Yes,
it
sir.
depends on the question, what the question is trying to ask. Okay, now
Okay.
besides this, if you look at the equivalent mass of different substances, they apply the different formula. So for different substances, calculation of equivalent mass, the formula goes like this. Number one, the first one is like this: equivalent mass of acid. Acid. Find the equivalent mass of an acid. Acid can be hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid. So you have to get the equivalent mass of the acid. Just work out the molecular mass of the acid. Molecular mass of the acid. Now, if it is an acid, you have to get its basicity. So, basicity, B-A-S-I-C-I-T-Y, basicity of acid. For example, one example, I'll just do it for you all over here. Say, I want to calculate equivalent mass of, say, sulfuric acid, okay? Sulfuric acid. So, sulfuric acid, the molecular mass becomes 2 plus 32 plus 60 plus 64 divided by basicity of sulfuric acid is 2 divided by 2. Are you getting it? Basicity means what? What is the definition of basicity? Basicity means number of replaceable hydrogen atoms or ions present in the acid, no? Isn't it? So that's why this basicity of sulfuric acid is 2. So if we simplify this, it comes to 94, 96, 98. 98 by 2 comes to 49. So that is the equivalent weight. Grams per equivalent. Unit is gram per equivalent. Okay. So the equivalent mass of sulfuric acid is 49. Did you understand? Did you understand, boys?
Yes, sir.
Okay, so next one. This was one formula for an acid. Okay, number two. Number two is called equivalent mass of a base. Equivalent mass of a base. To get the equivalent mass of a base, here you can apply the formula. Again, similar formula where we have to use molecular mass of base and the basicity. The for a base we determine its strength by a term which is called acidity. Okay, so the acidity of base. So this is the formula to get the equivalent mass of a base. Now let's do an example here also. Example, if I say equivalent mass of, say, let's take calcium hydroxide. Okay, calcium hydroxide, equivalent mass of calcium hydroxide. Calcium is 40 plus oxygen is 2 atom, 32, 60 to 32, hydrogen 2 on the 2. So divided by, over here, how many hydroxyl ions it is possessing? It is 2, no? So divided by 2 over here. So here you get 72 plus 2, 74. 74 by 2 comes to how much? 2 3 is 6, 2 7 is 14. So answer is 37. So that is the equivalent mass of calcium hydroxide, which is a diacidic base. Okay, it is a diacidic base. So hope this is clear to all of you. Okay. Now moving to the other formula, number 3, the third formula for equivalent masses. Now say if you are told to find the equivalent mass of a salt, then what will you do? So here the formula is here, equivalent mass of salt. Whatever salt you take, you can take sodium chloride, okay, potassium chloride, sodium carbonate, all any salt you can take. Equivalent mass of a salt, say the formula is again molecular mass of salt divided by uh, total positive or negative valency. Total positive or negative value. I'll come to the example. I'll explain you. This total positive or negative valency, it has been given a term. It is called n factor. Okay. Now let me clear this formula by doing one example. Okay. Say, for example, if you are told to find equivalent mass of salt, let's take a good one. Calcium phosphate, Ca3PO4 twice. So that's calcium phosphate. Okay. Now to get the equivalent mass of this salt calcium phosphate, we have to know the molecular mass of calcium phosphate. So calcium phosphate 40 into 3 for calcium. Then phosphorus, phosphorus What is the atomic mass of phosphorus? It will be 2 into phosphorus atomic mass. It is 31. Plus oxygen 16 4 the 64 plus 2 16 6 the 96. So this is divided by over here. What is the total number of positive or negative valency? Positive valence is plus 2. Okay. Have a look over here very carefully. Okay. Ca it's plus 2 and phosphorus is PO4 minus 2. PO4 minus 3, sorry. Okay. Now over here, total positive or negative valency, or we can talk about the n factor. Okay, here. So this is PO4. This is
Sir,
twice. Yes.
the mass of oxygen should be 16 into 8, no?
Yeah, sorry, sir. 16 8. 16, I just see mistake over here. 16 to 8. Okay, this one 6 is 48. 8 1 8 plus 4 12 128. Sorry, it's 128. Okay, fine. Okay, mathematically I was wrong. Okay, good. So it's 128. Now, after that, which valency is higher? Calcium, it is plus 2. Okay, whereas
Negative.
phosphate PO4 PO4 negative valence is higher, no? So it is minus 3 and 2 phosphate, no? So minus 3 into 2 is 6. That is what we have to put over here. Okay. So look for the valency. Whenever you are told to get the equivalent mass of a salt, no? That time you have to be careful with the valency, which valency you will take. Whichever valence is higher, no? If the positive valence is higher, you take that. If the negative valence is higher, you take that as well. Now, here in this case,
So,
the negative valence is higher. Yes, tell me.
so why did you take 6?
Oh, 6, yeah, correct. Phosphate, no, PO4 valence is how much? Valence is minus 3, right? And
Yes, sir.
in the formula, how many phosphate ions are there? How many phosphate?
2.
2. So that's why,
2.
that is why minus 3 into 2. Without the symbol, don't take this minus sign. It is coming 6, isn't it?
Yes, sir.
Are you getting it?
Yes, sir.
This is a trick. I'm not going to explain this in detail, but this is the tricks I'm telling you. Okay. Okay. Because these things
Okay.
did not explain. This factor, this 6 is called n factor. Otherwise, if you find it too confusing, then remember higher, whichever is higher, total positive higher valency or total negative higher valency. Okay. So that way you can get it. Got it now? So this was a good example which
Yes,
I've
sir.
taken because others are easy examples. So with the help of what you call this example, it is possible for me to explain everything over here. Okay. Now that was equivalent mass of what you call salt. Now, for example, the next one, the number 4, if you are told to get the equivalent mass of an oxidizing agent, equivalent mass of an oxidizing agent. Now, for this also there is a formula. So we have to work out the molecular mass of of oxidizing agent, molecular mass of the oxidizing agent divided by the number of electrons. Number of oxidizing agent, they take in electrons. So number of electrons gained by whom? By 1 mole, by 1 mole of it, by 1 mole of whom? The oxidizing agent. So this is the formula for calculating the equivalent mass of an oxidizing agent. Now let's take one example with potassium dichromate, potassium permanganate, manganese dioxide, lead dioxide. Let's take any one difficult one so that it will make the idea very clear. Let's take potassium permanganate, okay? AmNO4. Potassium permanganate. Let's get the equivalent mass of this potassium permanganate, okay? So here the formula is molecular mass of the oxidizing agent. So this one is an oxidizing agent. I think you must have learned chemical equation in class 10 in the chapter, say study of compounds, hydrochloric acid, where this what do you call this potassium permanganate, it is reacted with concentrated hydrochloric acid. This reaction I'm talking about, where it is producing potassium chloride plus manganese chloride plus water plus chlorine over here. It is behaving like the oxidizing agent because it is oxidizing HCl to chlorine. Okay, so that's why this reaction, in this reaction, KMnO4, it is the oxidizing agent. So I'm talking about potassium permanganate. Okay, so here the molecular mass, if you work out the molecular mass of potassium permanganate, then you will find that you'll find over there that potassium, it is 39. Manganese, it is 55. Oxygen is 16 for the 64. Okay, and then over here, what you call number of electrons gained. If you look at the number of electron gains that we have learned from the chapter, what you call redox reaction chapter. From the redox reaction chapter, you must have learned. I have taught you how to balance ionic equations, like from permanganate, potassium permanganate, the permanganate ion, MnO4 minus ion. If you balance the equation, this MnO4, it is becoming Mn plus 2. Mn plus 2 over here. Mn plus 2. Along with Mn plus 2, there is water also. So I put water also over here. So to balance the equation, it is an acidic medium over here. So in an acidic medium, if you look at the reaction and try to balance it, okay, here, if you balance the hydrogen over here, oxygen is 4. So we have to put 4 over here to balance the oxygen. The hydrogen is becoming 8. So 4 to the 8. So I put over here plus 8H plus. Now after that, I balance the charges. Over here plus 2 charges. Over here 8 positive charges, minus 1, 7. So I have to add 5 electrons here to make it balanced. Both the side charges are balanced. So this is the concept from the chapter redox reactions. Very important chapter. Now number of electrons gained over here is 5. So I'll put over here 5. So this becomes 158 divided by 5. So whatever you get the answer, that will be your
We need to add in left hand
pardon?
side only.
Pardon?
5 electrons.
Yeah, electrons you can put
So
here
that
also.
5 electrons we need to add.
5 electrons, it's been taken by whom? Manganese permanganate ion. No? Potassium permanganate, it is receiving 5 electrons. That is how it is being, taking electrons. It is the oxidizing agent. That's why it is producing Mn plus 2. Isn't it? Yes or no? Are you getting it?
Yes, sir.
Okay, if you try to work out the valency of manganese in permanganate ion, you can get the value over here. There will be increase of valency. Increase of valency is what? Oxidation. Okay, so that's how you can work out over here what is happening and get the number of electrons. So if you divide this 158 by say 5, you should get approximately around 31 or 32. 31 point something 6. Okay, that is the equivalent mass of this what you call oxidizing agent. Okay, so similarly you can also work out number 5. I'll just take a little bit more time. Equivalent mass of say reducing agent. The formula is similar. It's a similar formula. Molecular mass divided by number of electrons lost. Reducing agent, they lose electrons and they reduce somebody, but they themselves get oxidized. The number of electrons lost by one molecule of the reducing agent. So this one also, this is one formula which can be used to get the what you call equivalent mass of the reducing agent. We can over here talk about what you call oxalic acid. Oxalic acid. If we talk about oxalic acid, the formula of oxalic acid is H2C2O4. Okay. Now oxalic acid is present in the form of crystals. Okay. So here, if you work out the molecular mass of oxalic acid, it becomes 2 plus 24 plus 64 plus 18 to 36 divided by over here. Number of electrons need to be calculated. So to calculate the number of electrons in this formula, you can write down the ionic equation. Oxalic acid, oxalate ion C2O4 minus 2. When it is getting itself oxidized, it is producing carbon dioxide gas. So to balance the what you call see, the number of carbon atoms need to balance, because here is 2, so I put over here 2. Okay, so oxygen will become 4. Oxygen is 4 now. Now number of electrons has to be balanced, because here there is 2 negative charge, here there is no charge. So I'll put over here plus 2 electrons, or I can put the electron here also, minus 2 electrons. That means it is lost. Okay, so number of electrons lost is 2. So I'll put over here. So if I simplify this, it becomes add this 90, 94, 100, 124, 126, 126 by 2. Okay, this will give me 60, 63. So that is the equivalent mass of the reducing agent, which is the oxalic acid. Okay, so this is how we can work out the equivalent mass of the oxidizing agent, or the what you call reducing agent. Okay, so I think it's already time up. So I will like to stop my class here only, and in tomorrow's class, the remaining portion from this chapter, which is an important chapter, to continue with so many other chapters in chemistry. It is a very, very important, relevant chapter for both class 11 portion and class 12 portion. That's why I am revising this chapter properly. Okay, so with this, I would like to end my class here. But before that, just hold on. I need to record the attendance. Okay, then only you may leave the class. Okay, just a second. Just a second. Okay, attendance is downloading. It is downloaded. Okay, thank you so much. Have a nice day.